Shame.
Shame with you. Product rule. So what we're doing here, we have the product rule. That word product, that means when we're multiplying two things together. And this is going to be the product rule here. If we have some function y that involves the multiplication of two functions, like in all of these examples, right? You can see we have 5x multiplied by 2x take 3, x cubed multiplied by this part here. So we're going to use the product rule here because there's a times in between them. Now, if we were to use a strategy that we're already familiar with, what we would do is expand it and then differentiate it, and that's a perfectly suitable way of doing so. However, it wouldn't be very feasible down here, right, in this example, because we would have to expand this cubic and then distribute an x squared term and then differentiate. So there's a fair bit involved. You could do it using processes you're familiar with already, but instead we're going to look at using the product rule, and the product rule is going to help us answer particularly some more challenging differentiation ones without the need to expand and so forth. So, what we have to do is we have to first recognize I have two things that are multiplying each other, and I need to recognize what are those functions that are multiplying each other. Alright, so u we always call the first function, which is 5x, and v is the second function, which is going to be 2x take away 3. We then differentiate each function. Okay? So the derivative of u we just call u dash, and 5x, the derivative of 5x is 5. We differentiate v, the derivative of 2x take 3 will be 2. And then we just follow the rule. If we have y is u times v, then the derivative is u dash v plus uv dash. So u dash v, so we can go f dash of x now. Here's f of x, we're moving to f dash of x. F dash of x is u dash v plus u v dash. Okay, full marks then. However, we can expand and collect like terms and so forth, but we do have full marks here. Alright, so 10x take 15 plus 10x, we have 20x take 15. Okay, move on to B. First step, identify what is it that we're multiplying together. We have u is x to the 3, and v is the cubed root of x, which I'm going to express straight away as x to the power of a third. Take away 5x. So we have u and v. So u dash then will be 3x squared, and v dash will be a third x to the power of minus 2/3. Okay, just using the power rule. And the derivative of 5x will be 5. So we just write everything out, u dash, v dash, and then we smash it all together. U dash v, so we've gone from y, the derivative of y is dy on dx, just maintaining that correct notation. U dash v plus u v dash. Okay, again, we could expand and simplify, start to collect like terms. Just to recap, we know how to distribute that and multiply that out, right? So I might just say what we would do here. The number, the third would just stay out the front. These have the same base, so then we would add the powers together, right? Just using the index laws. Full marks there anyway. Let's move on to C. All right, u is going to be x squared, and v is going to be this whole component here, including the power of 3 on it. So I've just sort of brushed it with my maths jumper there. So that's going to be 2x take 5 root x to the power of 3. We have to include the power of 3. It belongs to the second part of the product. Okay, u dash, that's easy for us to differentiate. That's 2x. But v dash requires, does anyone know what rule we need to use? Chain rule, very good, Trey. So here we have a function to the power of n. So I'll write out the chain rule for us again. Okay, that's the chain rule. When we have a function to the power of n, we differentiate the inside, and then we multiply it by the power, and then we have the function to the power of the power take 1. That's the chain rule. Now, so you can see how this compounds, right? We did the chain rule last lesson, and today we're doing the product rule, but in the product rule, we're still using the chain rule. So those skills, you can think of it as a tower, right? It builds up. In order to access this level, you have to have seen the level underneath. All right, so for v dash here, all right, the first step is we differentiate the inside. All right, we need that part there. That's going to be 2, take away 5 times half x to the minus half. All right, so that's just the derivative of the inside here. And I should wrap the whole thing in brackets. All right, so we have 2 take away 5, and then the derivative of root x is half x to the minus half. We'll leave that part as it is. Then we have multiplied by n, where n is the power. So in this circumstance, multiplied by 3. Then we have the original function, 2x take 5 root x. And that's to the power of n take 1. So just to draw out the chain rule, f dash of x, n, f of x, n take 1. Okay, so this is why we should learn the quick procedure for the chain rule as well, so we can move straight from there to there when we're doing the product rule. Okay, so let's smash all of that together. We've got u, u dash, v, v dash. We're ready for dy on dx. It is u dash v plus u, and then multiplied by that monstrosity of v dash there. Now, I'll just say as well, order of multiplication doesn't matter. You'll hear me say this a fair bit. So for example, 1 times 2 is the same as 2 times 1, right? If you're multiplying those numbers together, it doesn't matter what order you're multiplying them in. So the same with the chain rule. You'll see it represented in multiple ways. Sometimes people they write it like this: n f of x, n take 1, multiplied by f dash of x. Okay, so both of those will mean the same, and they'll both help you to arrive at the same answer. All right, quick recap. Identify u, identify v, differentiate both, smash them together. Down here it gets a little bit tricky just because we had to use the chain rule as well. It will start easy, it will get more complex. Probably today we'll have a look at the quotient rule as well, just because that, like both skills link quite well together. So let's get started on